Hi there, and welcome back to the next set of terms about molecules. And we have already talked a little bit about molecules, but this is going to take you into the in-depth terms and the concepts that go with molecules. So let's just dive right in here. If you are following along in the textbook, this goes with pages 81 through 83. There is a lot of reading that will help you really understand this if you need more than what I'm doing here. The first term is pronounced anion. It looks like the word onion. Anion, anion. And an ion is an atom. We just drew a model of an atom in the last video with a negative charge as a result of gaining electrons. And sometimes when one atom passes near another, it will steal electrons from the second atom. And when that happens, remember that plus-minus balance becomes unbalanced. And you have an anion that is the result. So anions have a negative charge because they've picked up electrons from some other atom. A cation is similar. It is an atom with a positive charge having lost electrons. And I want to not belabor this too much. This is not going to be something that you're going to have to worry about, I'm pretty sure. I just wanted you to know the definitions and to have seen the words before. So, a chemical bond. This one is a little more easy to understand. It is an attractive force between atoms in a compound formed by transferring or sharing electrons. If you go on to school and to college where you study chemistry, you will definitely learn more about bonds. But for us today, I'm not going to go into this in great detail. Here's what I want you to know, and I want you to watch what I'm going to do right here. Let's suppose that we have 3 little atoms out there just floating around. They're not connected. They are 3 separate atoms. So we have this one, and we have this one, and this one. Now, O means oxygen, H means hydrogen. So I have 2 hydrogens and an oxygen atom. Now please watch me. Watch the screen. Here is the bond. As soon as you connect them, you have a bonded molecule. Is it pure? No, it's not pure oxygen. and it's not pure hydrogen. This is not a pure element. It has two elements. This is called a compound. And I'm going to go ahead, let's skip down here to compound and write that in there. A compound is a substance made by chemically bonding atoms in fixed ratios. And I'll show you what I mean by that. We need to go back up here and get chemical formula, and then you'll understand what I mean. So this is not a pure element. It is a compound of oxygen and hydrogen. The chemical formula is a representation of the ratio of elements in a compound using element symbols. Remember when we looked at the periodic table, we talked about every one of them has a symbol. So we use those symbols and subscripts. And I'm going to show you what a subscript is. Let's just get the definition down and then we'll talk about it. And you can pause your video if you need to catch up. I know I've got a lot going on here. Okay, I want to zoom back in on this particular picture and I want to do a little bit of coloring. I want my hydrogens to be the same color and I want my oxygen to be a different color. If you've got different colors here, you've got a compound. This is not a pure substance. So I want you to think with me here. How many hydrogens do you have? There's the symbol, and we have two of them. Because remember, hydrogen I have colored off in blue. How many oxygens do you have? You write a capital O. There's just one, so we do not put a 1 there. That's not proper. You just leave it alone. You've got one O. What is H2O? Where have you heard that before? H2O. This is one molecule of water that we drink. H2O is the formula for water that we drink. So the chemical formula is the representation or the math, the picture of the ratio, the recipe of elements in this compound, hydrogen, oxygen, using the symbols, the H and the O, and the subscript. A subscript is that little tiny number down there that tells you how much to use. You use 2 hydrogens and 1 oxygen. And to make drinkable water, this is the formula that you have to follow. It is a fixed ratio. It's a fixed recipe that we have to follow. Okay, moving on to covalent bond. And this is an attraction between atoms. A bond is an attraction between atoms that share electrons. And I'm going to draw you a picture of that. If I can spell. So let's say that we have I'm going to zoom right here, that we have two atoms, this one and this one. I'm not even going to name them. We don't need to worry about that. And that this guy well, let me just keep it as simple as I can. Let's say that this guy has an electron and this guy needs an electron. So here is the covalent bond, and I want you to watch what's about to happen on your screen. Here comes this fella, and here comes that one, and there's the bond. That is a covalent bond. They are sharing an electron. So this little guy right here in the middle is the place that they're bonding. That is a shared point. That's a covalent bond. Okay, a double bond is a covalent bond, so they're sharing electrons. And I won't draw this one because I don't have enough room, with 4 shared electrons. So sometimes they can share more than one electron, and they're hooking up together at that point. A double bond is when you have 4 shared electrons. Okay, an electrostatic attraction is the attraction between anions and cations. And we're just going to leave it there. I almost just left that one out, but it was in our list. So, an ionic bond is an attraction that forms when atoms transfer electrons. And I'll draw you a picture. If you need to stop the video to catch up, please do so. So let me show you how an ionic bond works. Let's suppose that we have 2 atoms and they're not connected. And that this fella has 2 electrons and this guy has none. Okay, so this fella's over here, he has none, but he's looking for one. Okay, and so it says, all right, you have 2. We're going to transfer one of those right into this space. So we're going to give away completely. We're not going to hook on there. We're actually going to give away an electron. So we're going to send that electron over to that atom. And that is an ionic bond. It's different than this kind of bond. You can see the picture and know that the 2 are different. So in this ionic bond, the electron is transferred. It actually moves over to the other atom that needs an electron. Okay, just a few more of these very tough terms, and we will be done with this one. A molecule. I've drawn you some molecules of water in one very big molecule of water. Here's the definition of molecule. It is the smallest particle of a compound that still has the properties of the compound. In the ratio given by the chemical formula. And I'm going to show you a picture, so hang with me here. Okay, over here we have a bunch of H's and O's. Okay, so what if I broke down this a little bit? I'm going to take out that bond, and I'm going to take out that bond. I can't take out that bond, so let me go at it this way. Let's suppose that this particular piece breaks off. So here's what's going to happen. I went too far. I'm going to remove the bond. I'm going to break the bond off. So this fella is a free-floating molecule. He's by himself over here. Okay? Now, here's the thing that you have to understand. Did we change the recipe? This one has 2 hydrogens and 1 oxygen. Here I have, let me do it this way. The way I set up my picture, I can't break this off. There's 2 hydrogens and 1 oxygen. Here are 2 hydrogens and 1 oxygen. Here are 2 hydrogens and 1 oxygen. Okay, so these are all the same. This is still H2O, this is H2O, and this is H2O. They're all exactly the same. It's just that this is a bigger molecule, because it's got them all hooked together. And this is just a smaller one, but they're the same substance. The recipe, the proportions have not changed. Now, if I threw an extra O in there or an extra H, things would change. But as it is, this is water, and so is this. It's just that there's more of the second one. That's all we're talking about here. A molecule is either one. You can have this small molecule or this large molecule. It's still water. The molecule over here on the left is the smallest that you could break. If you break these bonds, you no longer have water. So we would not want to do that. Okay, polar and nonpolar. Let's move this up just a hair. Nonpolar is a molecule in which electrons are shared equally and remember what that's called when you share electrons. What kind of bond is that? And we're going to look back. I'm not going to tell you the answer. Let's just jump back and figure that out. When you share electrons, that is this kind of bond. So it is a covalent bond. Nonpolar is covalent bonded. The key, though, is that they are shared equally. Nonpolar is shared equally. So polar I need a little more space, is a molecule in which electrons are shared, so that's covalent. But they're shared unequally. Through covalent bonds. That doesn't change because that's sharing electrons. So that the poles of the molecules and poles are just the ends, are slightly positive or negative. So these polar ones have a slight charge at the poles. They're slightly positive or negative. And you don't need to worry about that. It's okay. If you understand that, great. If you don't, it's all right. Just move on to the next one. The unshared electrons are exactly what they say. They are pairs of electrons in the outer shell. Remember when we drew our model, we had those electron shells. Mother Nature allows 2 electrons in the first and then limited numbers in the next ones also that are not shared. They're literally unshared. So this definition is almost redundant. You can just read the term and know what they're talking about or what they mean. I know this set of terms is very tough, so I don't want you to fret about it. If you understand the pictures, I think you'll be just fine on this one. I will see you back for the next set of terms in the next video.